For today's lesson, we're going to be skipping a bit because we used some different materials for the last lesson, so we can go a little bit faster. So I'm going to turn over to I'm going to go through page 20. I'm actually going to pick it up at the bottom of page 21, and I think this is a good little exercise because it can be confusing sometimes. There's three closely related but different ideas here when we're doing these double identities and squares and things like that. So what's the difference between cos of 2 theta and cos squared theta? So the cos of 2 theta is going to look like this. Okay, and the cos squared of theta we write like this. Okay, so what do these mean? Well, why don't we pick an angle? Why don't we say, okay, how about we pick theta equals pi over 4. So in our unit circle, pi over 4 is right over there. Okay, so just a reminder that the cos of pi over 4 is equal to root 2 over 2. All right, so this part here, the cos of 2 theta means what is the cos of 2 times pi over 4? So the angle is going to be twice as much. Instead of taking my angle and stopping it at pi over 4, we're going to go twice as far. So in this case, it'll be the cos of pi over 2, and the cos of pi over 2 is equal to 0. Looking over at cos squared theta, and I've mentioned before, it's too bad that they write it this way. Really, the cos squared of theta it's the same thing as the cos of theta all squared. So in our example, it's going to be the cos of pi over 4 all squared. What is the cos of pi over 4? Which is equal to root 2 over 2. And when I square that, squaring that gives me the square of the numerator and square of the denominator. And the square of the numerator is 2, square of the denominator is 4, so I get 1/2. So are these things equal? No, 0 is not equal to 1/2. And so we can say these are not equal. So be careful when we're doing cos 2 theta and cos squared theta. Cos 2 theta is you're finding the x value of twice the angle of theta. Cos squared theta, you're finding the x value for the angle, and then you're taking that x value and squaring it. Okay. So what about this one? What about cos 2 theta and 2 cos theta? We've just moved the 2 around, right? So be careful about this. This 2 cos theta will be looking like this. Okay, so here what we're doing is we're doubling the angle. Here we're doubling the x value of that angle. So if we use that same example here, the cos of 2 times pi over 4 is the same thing as pi over 2, and that we just did that above is going to be equal to 0. Here this will be 2 times the cos of pi over 4, so that would be 2 times root 2 over 2, so the 2's would cancel out there and we would get root 2. So are these two equal? Not equal. So just I wanted to go over that page because I think it's kind of good to remind ourselves the difference between cos 2 theta, cos squared theta, and 2 cos theta. So now I want to go, and I don't think we have to do this page. I'd like to take a look at this page here, these guided examples using double angle identities. It says, choose the equivalent function from this list. Multiple choice, don't just guess, understand. So for part A, we're going to pick one of these values. Okay, so which one is right? 2 sine theta cos theta. So what we can do is we can go up over to our formula sheet and we can say, where do I get, I've been writing all over this thing, where do I see this 2 times sine times cos pattern? And a little bit of hunting around, you see it. It's right there. It's the double identity for sine. Okay, so if I go over here and I can write something in a similar pattern, and this is this 2 times sine theta cos theta. This is what I found in my formula sheet, right? So our example here is going to be, well, then if it's 2 times the sine of 30 degrees times the cos of 30 degrees, then this will be the sine of 60 degrees. And my answer then would be the sine of 60 degrees b. Okay, let's try part b over here. Cos squared pi over 6 minus sine squared pi over 6. So we're looking for cos squared of an angle minus, so this is what we're looking for. We're looking for cos squared theta minus sine squared theta. And where do we see that over here? It's alpha, but whatever. Okay, here it is. It's the this one here. It's equal to the cos of twice the angle. So I'll write it over here is equal to, make some space, cos of 2 theta is equal to that. So in our particular application here, if it is cos squared of pi over 6 minus sine squared of pi over 6, this would be the cos of, what is twice of pi over 6? It's pi over 3. So my answer will be the cos of pi over 3. There we go, there's my answer. Okay. I'll put this one down here, 8 times cos b sine b. Now I don't think we're going to find an 8, but look at all this. We've got 4s and 16. So there's either we're dividing by 2 or multiplying by 2. Okay, so well, this reminds me actually a lot of what we just did here, this sine 2 theta, right? So how about if I write it out and I could say, okay, if the sine, oh, it's too big. If the sine of 2 theta is equal to 2 times sine theta cos theta, what would I have to do to both sides? Well, I guess first of all I should have written, instead of theta, I should have written the b, the beta. Okay, so here I'll sloppily fix this here. I should be consistent. Okay, now what would I have to do to both sides to make it look like this? I'd have to multiply both sides times 4, right? So I will put a 4 here, and then I'll put a 4 there. Okay, so this would be the same thing as 8 times, and I can switch the order, that's okay, 8 times cos beta sine beta, multiplying 2 times 3 and 3 times 2. Multiplication doesn't matter which order you're doing them in. So instead of saying sine beta times cos beta, I can say cos beta times sine beta, and this will be the same thing as 8 times the sine of 2 beta. So oh, sorry, 4. How did I do that? I saw that 4 and I copied down an 8. There we go. So my answer will be 4 times the sine of 2 beta right here. Okay. Next question. Okay, similar, isn't it? So sine times cos again. So I'm going to say, well, I can multiply this like this, factor out a 2, because I need a 2 inside of there. Sine of 6x times the cos of 6x. Oh, but this is not the one I'm looking at here. Sorry. Oh, so yeah, that looks right. So that will be equal to 2 times the sine of 2 times 6x, which is 12x. Okay? So 2 times the sine of twice the angle. And maybe it helps to have written down here. So what I'm writing down now is what you would have seen from the formula sheet, right? So you see the differences between here and here is I substituted 6x for theta, okay, and then for 2 theta becomes 12x, and I multiplied, sorry, and I made one mistake, because this 2 should not be there, and I multiplied both sides by 2. So you can see this is the direction of the thinking. You say, okay, I found this in the formula sheet, and so how does that compare? Well, I need to factor out this 2, because I need to find a 2 times the sine of some angle times the cos of that angle, and then the angle gets doubled over here. So my answer would be, which letter is that? That looks like C. Okay, I hope that is helps a little bit. Let's do some proofs, because that's, again, this is we're doing some proofs here. Maybe I can zoom in just a little bit because I got lots of writing to do. There we go. Okay, so sine 2 theta times the secant of theta. When you're looking at the sine of 2 theta, it's kind of a nicer one than the cos of 2 theta, because when we look over at the formula sheet, there's only one version of the sine of 2 theta. And for the cos of 2 theta, there's 3 of them, although they are very similar. And if you pick one that might take a little bit more work, you can, even if you choose incorrectly, so to speak, of which cos one to do, you can usually get to the right answer anyways. It just may take you an extra step. So the sine of 2 theta, this piece here, that one there, I will be copying it out, will be equal to 2 times, oh that's way too big, 2 times the sine of theta times the cos of theta times the secant of theta minus the sine of theta. Okay, so I'll just highlight what I did. So that became that. In the next line, I'll take my secant of theta and change it into 1 over cos. 2 times the sine of theta times the cos of theta times 1 over cos minus the sine of theta. Okay, so now I can say in this term, I have 2 terms here. So my first term is this one. And in that term, you can think of this whole piece as the numerator and this as the denominator. So 2 times the sine of theta times the cos of theta times 1. So really we don't have to worry about that one. So we have a cos in the numerator and the denominator, so I can cancel that out. So in my next line from this term on the left, I will have 2 times the sine theta minus sine theta. So this reminds me of a lot of, say, 2x minus x, which is equal to just x. So in our example, 2 sine theta minus sine theta will give us sine theta. And the right-hand side is sine theta. So we have left-hand side equals the right-hand side. So we're good. Let's try this next one here. So we have 2 double identities. We've got the sine of 2 theta here, and we have the cos of 2 theta. So like I said, we have the choice of 3 different identities for the cos of 2 theta. So let's substitute our denominator in first. Maybe I'll be really nice and write it out first. Cos of 2 theta all over the sine of 2 theta. This is the left-hand side, and then the right-hand side is equal to the cotan of theta. Okay, now, so like I said, let's substitute in that denominator first. The denominator will be 2 sine theta times the cos of theta. And now we have this, which one of these shall I pick? So I got 1 plus, and now what should I put inside of here? Which of my 3? So I'm going back to my formula sheet. And just real quick, it's 1 plus whatever I pick. So would it be better to pick, and I'm going to do some erasing here. Would it be better to pick 1 plus this, 1 plus that, or the third one, 1 plus that? And when I'm looking at this, all 3 of these have 2 terms, and it's nice to get rid of terms. Having fewer terms is better than more terms. If I pick my third example here, and I get 2 cos squared, if I put this in here, 2 cos squared theta minus 1, what's nice is this one and this one, they're going to cancel each other out, right? Hey, I wonder if I can do something crazy here. If I go copy, I'm getting a little nervous, but maybe it just might work. And then if I go over here and I go paste, oh, and it's kind of big, isn't it? This is almost fun. Oh, there we go. Something like that. Actually, I gotta erase this old stuff first. So bear with me. And now, no. Oh, darn it. I was doing so good there for a while, guys. Okay, so if I take this, oh, I gotta grab it again. Okay, so I'll grab it again, and then we'll put it over there. Oh, okay, I'm not really sure if that saved me any time. So now, when I do take away the brackets, because it's adding, nothing really changes with the brackets. It's not like I'm changing the signs because I'm subtracting. So this one here and this one here are going to cancel each other out. So in my next line, I will have 2 times the cos squared of theta all over 2 times sine theta times cos theta. And now I've got some neat things I can cancel out. My 2's will cancel out, and one of my coses from the numerator will cancel out my only cos from the denominator. And guess what? We're there because the cos over sine is equal to cotan of theta. And we are able to write those magic words, left-hand side is equal to right-hand side. Let's try our example number 3. We have 1 minus the cos of 2 theta and 1 plus the cos of 2 theta. And again, we're going to be trying to choose good examples for the cos of 2 theta. So we're thinking ahead. We want to get sine squared, looking at the sine squared over cos squared. So if I write left-hand side, 1 minus cos 2 theta over 1 plus cos 2 theta. And I want eventually for it to look like tan squared theta. And I'm thinking tan squared, here bubbles, I'll do my own bubble. Tan squared theta is equal to sine squared over cos squared, right? So I'm thinking, hey, which cos shall I pick up on the top and on the bottom? I wanted something that gives me a nice sine squared up there maybe, and we'll just see what happens. Let's go to my formula sheet. So, well, here's one here. Cos 2 theta is equal to 1 minus 2 times sine squared theta. Okay, let's try that. 1 minus 2 sine squared theta. 1 minus, oh, what was that again? 1 minus 2 sine squared theta. Over, now 1 plus cos 2 theta. And I'd love to have something where I get cos squared. So I'll go over here and I say, oh, this is a nice one. 2 cos squared theta minus 1. Okay, so now in my numerator, when I get rid of the brackets, I get 1 minus 1 plus 2 sine squared theta all over 1 plus 2 times the cos squared of theta minus 1. Now, hey, we've done really well, haven't we? Because the 1 minus 1 turns into 0, and here is a 1 minus 1 turns into 0. So now I get 2 sine squared theta over 2 cos squared theta. I don't want to show too many steps in one line of work, so even though I'm tempted to cancel out those 2's at the same time, I only really want to show one step at a time. So now I'll show my dividing the top and the bottom by 2, and now I'm done. All I got to do is go out there and claim the prize and say sine squared over cos squared is equal to tan squared theta, and so I have left hand side is equal to my right hand side. Excellent. Okay. Is your algebra correct? Have you chosen the correct double identities to use on the left? And really, we could have picked something else, and it still could have worked. There's your check on your understanding, and you'll notice, if I zoom out a little bit, number 4 is a bit more challenging, and number 11 gives you a just to let you know this one is more challenging. So 4 and 11 are the crazy ones. And the answers are inside the front cover, and the reason why it says use your own paper is because there's no way you can do a whole proof in that short amount of time. Okay, so good luck, and we'll see you in class.